In this SPSS assignment quick tip, I'm going to show you how you can use SPSS syntax to write commands to request simple effects that are important for helping us to interpret significant interactions when we're conducting a factorial ANOVA. In this example here, I brought up a data set in which we're going to be conducting a two-factor ANOVA looking at the joint effects of participant sex and weight status according to BMI, categorized as or grouped as either healthy weight, overweight, or obese, on participants' self-esteem score. So this is going to be a two-factor ANOVA. One factor has three levels: weight status, and that's a between subjects factor, so participants are either of healthy weight, overweight, or obese. And our second factor has two levels, which is also between subjects, and participants are either female or male, so that second factor is sex. So we're going to run a two-factor between subjects ANOVA, since both factors are between subjects, to examine the effect of both of these jointly on self-esteem. So in particular, we're interested in the interaction between sex and participants' weight status on its effect of self-esteem. So we are going to want to anticipate or hypothesize a significant interaction between those two factors, and likely, assuming there is going to be a significant interaction, we want to interpret specific differences in light of that interaction. In order to do that, we need to generate what are referred to as simple effects. So first, let's set up our ANOVA in this case. So we would go to Analyze, General Linear Model, and then select Univariate. Again, since both of our factors that we're looking at are between subjects, this is the appropriate test to run. If one of them were within subjects, we might go to the Repeated Measures ANOVA dialog menu, but we're going to use Univariate here. In this case, I'm going to move self-esteem to our dependent variable, so that's our outcome or dependent variable. And the two factors we're interested in this example are sex and participants' weight status in those categories. And I'm actually going to switch these here because I want weight status to be my first factor and sex to be my second factor. A couple things that are kind of default to include within a multi-factor ANOVA. It's always good to help visualize, in the case if we have any interactions, to include a plot that looks at the interaction. So in this case, I'm going to look at sex separately in two separate lines and see the pattern across of self-esteem across weight status categories. So in order to do that, I'm going to move weight status to our horizontal axis, and sex will be represented by separate lines on the line plot. We then go ahead and add that here and click Continue. The next part is to specify specific options we want in our output. The first thing here is under the Options menu dialog box, if we see the estimated marginal means, I want to select all of these and actually display means and conduct post hoc tests to compare all these effects. Now, I am going to choose, instead of the least significant difference option, the Bonferroni, because it applies corrections for inflated type 1 error rates automatically and is thought to be more conservative. So we're going to use the Bonferroni test here. I'm also going to, just to keep things simple, request descriptive statistics, which will give me means for all of these different classifications or groups, as well as estimates of effect size and the homogeneity of variance test. So we're going to go ahead and click Continue. Now, I actually have my factorial ANOVA from a base standpoint all set up, so I could go ahead and click OK to run it. The problem is SPSS doesn't have a default way from the drop-down menus in which to request simple main effects to look for differences that are important for, or significant differences that are important for interpreting interaction effects. But there is a simple way to do this by writing in SPSS syntax to include those simple main effects. So instead of clicking OK to run this, I actually want to add a little bit of language to this command so that SPSS can generate these simple effects in my first analysis that I can use to interpret should we find a significant interaction. So I'm actually going to go to paste, and what this does is it generates the command needed to the command needed to run the factorial ANOVA into our SPSS output. But I'm going to make a few modifications here, and these are the modifications that we can make in order to request these kind of post hoc simple effect analysis to help interpret significant interactions. So in particular, we see that by default SPSS does allow us to compare main effects across means. So it'll provide Bonferroni post hoc tests comparing the 3 weight status categories to see if there are significant differences in self-esteem scores for between the 3 different weight status categories. Same with sex. It'll provide mean differences between males and females in self-esteem should we find a significant main effect of sex on self-esteem scores. However, while it provides tables that give us the estimated marginal means for the interaction, it doesn't actually provide comparisons or pairwise comparisons between all the different conditions to see where there are significant differences between kind of categorizations of weight status and sex. So in order to do that, we need to write in the language to allow us to do that. And we can use the commands above here for the main effect pairwise comparisons as a guide to help us. So in this case, what I want to do is also compare, but for interactions, what we want to do is isolate one variable so that we can compare that variable across the different conditions of the other variable. So in this case, we want to compare weight status and do that using a Bonferroni correction. And what this will do is it'll generate simple effects that examine the 3 categories of weight status separately for the 2 different sexes. So for males, it'll look at where differences are between overweight or between healthy weight, overweight, and obese for males, and then as well separately for females. If we wanted to, we could also specify looking at it the other way just to get a very overall picture of where the cell differences are for interactions. So we could copy and paste the same estimated marginal means language in our syntax and make one slight change here and allow us to compare sex for each of the different weight status categories. So in this case, what we would be doing is comparing self-esteem scores for males and females of healthy weight to see if there's any differences in the healthy weight group. Compare males and females in the overweight group to see if there's any differences in self-esteem there, and then compare males and females in the obese group to see if there's any differences in self-esteem there. So this provides us both ways of looking at the interaction. Generally, you only need to have one and interpret one, but we're going to look at both to help us get that full picture. You can then go ahead and highlight the entire command here, and you can either hit Control R to run that command. You can right click and go down to Run All, or you can click either this play button, which will run that, or run it the selection here. So there's a lot of options for running that command. I'm going to go ahead and choose this last option to run, and you'll see in our output here our entire factorial ANOVA is generated, and if we go down, we'll be able to see those simple effects we requested, looking at those pairwise comparisons here. So why this is important is it helps us flag potential significant differences between categories, should there be any. So here was the first one looking at differences across weight status categories for females and then males, and then differences between males and females for each of the different weight status categories.